Hey everybody, thanks for watching. Ryan from PlanetTogether here. So in this video, we are going to take a look at the PlanetTogether advanced planning and scheduling platform. We'll start with a background on the company and why APS, Advanced Planning and Scheduling, is amazing. Just kind of how it came about, what are the origins. And then we'll jump into the software and take a look at how it looks, get some look and feel, and I'll show you some of the few cool features that we have that will help make your life scheduling much easier. So let's get started. So at PlanetTogether, our mission is to make the planet more productive, one manufacturer at a time. And we do that in two different ways. So of course, you are implementing a software package that's going to speed up the process that it takes you to do scheduling every day. So for your scheduler, it is going to help them save time. But of course, the reason you buy a system like this is so you can prioritize jobs to run together, operations to sequence together, to save you changeovers, right? So we're going to save you time creating the schedule. We're also going to make a more efficient schedule. And we are going to hopefully save you time on rework, right? You're going to be able to quote better lead times, quote better delivery dates, and make your life a whole lot easier. So this is a picture of your supply chain. Everyone's seen this, but everything from raw materials to your consumer. And delays and disruption can happen anywhere in the supply chain, right? Raw materials don't come in, your suppliers have long lead times. You've got distribution costs, your customers always changing their mind, that sort of thing. Well, what I've highlighted in red on the side here is basically what PlanetTogether is going to help you with, right? So we're focused in the manufacturing area. I guess the biggest thing that stands out with a software package like this is that you're going to be able to create a schedule very quickly. So the manufacturers that get the most benefit out of our product are high product mix, complex operations. If you're making the same thing all the time, you're not going to probably get as much benefit from an APS system as if you are making different types of items. They've got different changeovers. You've got to utilize your facility making a large product mix. So how do you run those? How do you run those product mixes in the most efficient way, right? So fluctuating demands, costly changeovers, need for agility and replanning quickly, and just the general ability to have different production options, right? So if you find yourself in that category, then I think you're in the right place, and hope you enjoy this video. So a little bit about PlanetTogether as a company and its origins and how we all got here today. So really, PlanetTogether got its start at Cornell University. These two professors, Conway and Maxwell, pictured there, they literally wrote the book on the theory of scheduling, essentially using computer algorithms to create a efficient sequenced schedule. Anyway, along the line someplace, they created a company called Seaway Systems, which was a joint venture between Cornell University, Hewlett-Packard, General Motors, and eventually Seaway Systems, through some acquisitions, ended up being part of a company out in San Diego. Our CEO, Jim Serra, was the product manager for that company, and our CFO, Larry Hargis, was the lead APS developer for that company. So that's how the two of those guys met. And around, I believe, the early 2000s, the company was acquired again, and essentially the APS product died at that point. So fun story, Jim and Larry broke off on their own and wrote PlanetTogether planning and scheduling software. So we've, I guess some more background, we are headquartered out in San Diego, been around since 2004, and And that's about it. So I always like to go into this exercise. It's fun. You know, basing our story here off of Conway and Maxwell, why do we need these advanced algorithms for scheduling? Can't we just create a schedule? Can't we just line things up? What's so hard about this, right? And what's so hard about getting a computer to do this? So this is a fun little exercise. Let's do some math, right? So here's our scenario. We've got one resource. We've got 15 orders or jobs on a schedule on that resource. And one operation per job step. So say we're trying to schedule 15 things. What order do we put them in? What's the best order to put them in? Right? So how many different ways can we sequence 15 things? Well, let's take a smaller number. Let's take like 3 things. What's the best way to schedule 3 things? I've got a job A, B, and C. Well, I could go ABC, or I could go ACB, or I could start with B and go BAC or BCA, or I could start with C and go CAB and CBA, right? So to sequence 3 jobs, we need to basically try 6 different possibilities to determine which one's the best, all right? So how do we do that, right? It's 3 factorial. 3 times 2 times 1 would give us 6. So in this case, in our equation here, for 15 orders, 15 factorial, 1.3 trillion different ways to schedule those 15 orders. That's a lot, all right? A lot of different ways. So, well, we've got computers to figure this out, right? So it should be pretty quick. So let's take a fast CPU. It can run at 4 gigahertz, let's say. That's 4 billion transactions a second, all right? So we'll do some simple math here. 1.3 trillion transactions, 4 billion transactions a second. That gives us a result of 5.5 minutes to run through every single one of those 1.3 trillion possibilities and determine the best sequence. All right, so 5 minutes, you might say, oh, that's not too bad. But let's just expand our numbers just a little bit, right? So what if we add 5 more orders to this mix? So 20 orders we need to schedule, right? Well, 20 factorial, 2.4 quintillion different permutations there. So we subtract this out and divide this out, and it would take 19.2 years to go through all of those different combinations of orders, different sequences, all right? So obviously that's not going to work for us, right? I mean, everyone probably has more than 20 orders that they want to schedule. Like I say on my next slide here, so what's the real world, right? Real world is we got high volume data, complexity, a lot of communication issues, business priorities to schedule by. We're planning out 1 to 2 years. Got hundreds of resources, thousands of operations, hundreds of thousands of inventory SKUs. Basically, this is a massive dynamic math problem, right? So we need, and what PlanTogether uses is rules and heuristics to determine what's the best operation to schedule next based on what's already been scheduled. And we'll kind of get into how that does that. So just for fun here, some other numbers to play around with. Number of playing cards in a deck, 52. So how many different ways are there to order those 52 cards? Well, 8 to the 67 power times. So to put that in perspective, right, let's take how old the universe is. 13.8 billion years, which is 4.3 to the 17th seconds. So if you look at those two numbers, even if you shuffled that deck of cards once every second for the history of the known universe, you may never, the probability of you coming up with the same sequence of cards in that deck is almost 0, right? So just some interesting math there, some fun with numbers. Basically, yeah, we need a better way to do this. So how does PlanTogether do this? Well, there's 2 main kind of controls that we have in the system. One I call theory of constraints. Most of you have heard of it. Eli Goldratt wrote the goal, basically wrote a story about the theory of constraints, basically protecting and optimizing your bottleneck against variability. Nothing matters more than your bottleneck. You can't starve the bottleneck. You want to keep your work flowing through the bottleneck, right? I put Jeff Bezos up there because the goal is a required reading by all of his Amazon executives. So that must mean it's good, right? It must mean it's the way to go. Well, look, here's kind of how it works, right? So the whole idea with a scheduling software is, when do we release the work to be scheduled, right? Hey, it's due on Friday. Do we want to schedule on Thursday, on Wednesday, on Monday? Do we want to schedule it a month before it's due? Well, we've got controls over that, and we call them buffers. So we've got shipping buffers in our schedule. We've got inventory and drum buffers. So we can control these levers and tell PlanetTogether when to schedule the work. Do we schedule it 7 days before it's due? Or do we try, to release it 7 days before it's due? Do maybe we bring the POs in a week before they're due to be consumed? That sort of thing. And what's great about PlanetTogether is we have something called the drum buffer, which is more of a dynamic buffer in the system that looks at your bottlenecked resources, your constrained resources, and can create a buffer into those resources so that we don't starve them. That's the idea. So let's see. The next piece, so that was theory of constraints, kind of when do we release the work to be scheduled. And the second piece is, like we talked about before, this sequencing. So we've released all this work to be scheduled this week, but now we want to know what order do we put this work in? And that's where inside PlanetTogether we call optimization. So we have sliders in PlanetTogether. It's very easy, that let you set your priorities, right? So let's pretend like we've got these 5 orders at the bottom of the screen here. Which order do we want to sequence them in? Well, maybe we want to group like products together. So there's a slider for that. You can group your products together or groups of products together. Or you can sequence by reducing changeover time. There's lots of different ways to do it. And you simply set these sliders, and I'll show you that when we get into the software demo. You run your optimization, and you get your result. Right? And I should say it is significantly shorter than 19.2 years. Most of our optimizations, depending on the data, can take anywhere from a couple of seconds to, have I ever seen anything? Probably never seen anything over a minute. Depends on the data load, but obviously the more data, the more calculations, the longer it takes. But for a normal size company that we have, a standard size company, probably 3,000 to 4,000 orders, it only takes a couple of seconds to run our optimization. A little bit about data flow before we get into the software. So let's start with the groups of data that we have. I mean, there's PlanetTogether, obviously, it needs to know your capabilities and the capacity that you have in your facility, but it also likes to know your inventory level, so it can do some constraining by what's on hand and what purchase orders are coming in, that sort of thing. So I like to think of it as 3 buckets of data. So you've got your resource objects, your inventory objects, and your job objects. So resource objects are, what resources are available, what are the capabilities of those resources, what work centers are they in. You've got your inventory objects, like, what are your lead times or any attributes on items, like their color or the tools they use, that sort of thing, where they're stored, what their on-hand inventory levels are at this point in time, and what are the supply and demand of those? What are the purchase orders that are coming in? What are the sales orders that you have? And even what are the forecasts that you have against those items? And then really what ties the 2 of those together are your jobs, your routes, right? So what are your open production orders? What do your operations look like? What are the cycle times? What are the setups on those? And that sort of thing. And then the typical data flow, which we'll get into the next screenshot here, is you've got your ERP out there. PlanetTogether uses a SQL server to stage data. And so we typically will pull data out of the ERP, put it into a SQL Server database, and then pull it into PlanetTogether. PlanetTogether is multi-client, so you can have one server, multiple clients connected to it, and that's kind of how the data works between the server client. So just a little typical ERP PlanetTogether workflow. The the blue being some of the plan together actions. So typically, this is how something would happen. There'd be a demand signal inside the ERP. You can run planning in your ERP system and get some firmed production orders. Firmed or planned production orders are fine. We would bring those in to PlanetTogether. PlanetTogether would do its scheduling. It would, allocate material to those orders all at the same time. And then what we typically do is we'll send data back to the ERP. We'll send back production order start dates, stop dates, what resource they're running on, that sort of thing. And so that will feed back into your ERP. It will help you run your MRP process more smoothly, and just that you have all the data set up in there. So that's kind of the workflow. We won't get into it in the demo here, but PlanetTogether can also generate planned orders for you. So if you find that your ERP system is not doing a great job of planning the orders that you need to make, and maybe you can, you've got multiple level bombs and you'd like to, have constraints at each level of the bomb to determine what orders you should make and do different batching in that sense. PlanetTogether is really great at that as well. So if you're interested in that, please reach out and we can have a discussion about it. All right, so let's get into the software demo. The outline here is we're going to do some general navigation. I'll flip back and forth to the slide so we can see, but general navigation, what does it look like, how it's set up? We'll identify there's a lot of colors inside PlanetTogether, so we'll identify bottlenecks, how we do that, on-time delivery issues. We'll talk about optimization and sequencing and changeovers, how you can manually control the schedule. I think a lot of people think that, when they implement an APS system that they're going to hit a button, it's going to give them a perfect schedule. And while that is the dream, it rarely is like that. What we like at PlanetTogether is we I would say more than an 80-20 rule, I'd give it a 90-10 rule. You hit the optimization button, your schedule is going to get 90% perfect for you, and then we give you the opportunity to manually manipulate that schedule and make it exactly the way you want to run it, right? So that's the idea. So I'll talk about some manual control that we have in the system, and then we'll look at other types of constraints like material management, shortages, and of course we'll talk about running what-if scenarios and something we call capable to promise, or CTP, getting an order quote when you don't have an actual order in your ERP system. All right. So I'm going to flip over to PlanetTogether here. Now, I'm going to start really simple, and then we'll build up data on top of this and kind of have fun with it. So in PlanetTogether, this is what it looks like. There's a main toolbar with some functions that we'll go over in a little bit. The main screen, kind of the main view that most people like to look at, is the Gantt view, which is what you're seeing kind of on the left side of the screen here. We'll talk about this side in a second, but this is a list of jobs that we have in our system. We only have one job in our system right now, and we're going to talk about that one job. So in our make-believe facility here, we are looking at a chemical plant. They produce some pellets, some resin pellets, all right? So on the left-hand side here, we have your resources, mixer 1 and 2 and pelletizer 1 and 2. And you can have as many resources as you want in the system, but in this case, there's 4. Across the top here is the calendar. So, we're looking at Wednesday, Thursday, Friday, Saturday. You can zoom out as far as you want and zoom in as far as you want. You can plan out as far as you want. There is no limit. So yeah, there's really no limits in the system. It's really all kind of data dependent. What we see on the Gantt here, and we'll talk about these other green lines in a second, but what we see on the Gantt are a couple rectangles. These represent operations within a job. All right, so I'm going to click on this mixer operation, and I'm just going to zoom into this a little bit. So what we see here is, we know we have one job. WOSO5 is the job name. It has 2 operation steps. We have a mixing step and a pelletizing step. All right. You'll notice a blue line between them. That shows operation succession. All right. So these 2 operations are linked with each other. And that's really nice because if I move, I'm going to show you a little drag and drop here. If I move my mixer operation out in the schedule to Wednesday, it's going to automatically push my pelletizing operation out, okay? Same goes for if I try to move my pelletizing operation in, well, it's not going to let me. It's constrained, all right? So PlanetTogether is constraining that operation. It's not going to let me run it forward unless I move mixer out of the way, and then I can move my pelletizing operation up to it, just like that, okay? Pretty simple stuff. Couple other things before we get into the colors and all that. You'll notice PlanetTogether is set up with capabilities. All right, I don't think capabilities are foreign to anybody, but in this case, my operation step here needs a mixer, and you'll notice by these little green arrows, PlanetTogether is telling me that both of these mixers are capable of running this operation. So I can drag this from mixer 1 to mixer 2, no problem. I can drag it up there, no problem. If I try to put it on a pelletizer, well, it's not going to let me, right? It says it's missing the capability of mix on the pelletizer. So why is that important? Well, it's important because PlanetTogether knows all this information up front and can now place these jobs on the schedule for you where they optimally need to be scheduled. All right. So a couple more things. One of the questions we have is, how do we control our shift schedules? Like when work can be done, that sort of thing. When is a machine online? When is it offline? So that's one of the pieces of data that's usually managed in PlanetTogether. A lot of the other data is just imported in from data sets you already have from your ERP. But I can, I'll show you here, we call them capacity intervals, and I'm just going to make them big for a second just so we can see them. But you'll notice I've got first, second, third shift on every resource here. Now these can be highly customized any way you want. You'll notice they stop here on Saturday and Sunday. They don't run. Okay, so what does this mean? Well, it means that I can't do work. I can only do work on these green shifts. I can't do work on the basically the offline time where there is no shift. So for example, if I take this pelletizer operation and I try to put it where there is no green time, what it does is it just pushes it to the next available time. Okay, simple as that. Let's pretend for a second that kind of a scenario here. Maybe I know on Friday, third shift, we're not going to be able to run mixer 1. Okay, so it's really easy to change this to an offline time. I can open the shift, and you'll see all the kind of the fun stuff you can do with it. You can set up recurrences Monday, each day of the week for how long you want to run it for, that sort of thing. But I also have some options. I can turn it offline, or I can turn it to a clean out. We have 2 types of offline time. I'm not going to get into exactly what the difference is, but I'm going to turn it to a clean out. It's basically going to shut that machine down for that period of time. So if I save this, watch what happens. My third shift on mixer 1 turns blue to that clean out. And now take a look at what happens. If I try to run something on that shift, it essentially is going to do the same thing. It's just going to push it to the next available time. All right. Okay, pretty simple stuff. So I'm going to minimize my shift schedules for now. I think we've got the idea there. And we're going to look at some of the colors. Okay, I'm going to, we'll keep this job to one color right now. It's green. Notice it's green. And what I've got shown, there's a lot of labels and things in PlanetTogether. What I've got shown is called the timing segment. We're going to be back in the screen for a second. Notice when I turn on one of these segments, if I turned on timing and process and hit apply, my operations get divided into 2 separate segments, a top segment and a bottom segment. In this case, I'm looking at a processing segment, setup and processing. It shows me how long the job's running for. All right, so lots of different things. We're going to turn some of these on in a second, but for now, I just want to focus on timing because that's a very important one for us. You'll notice there it's green at the top for on time, and what we want to look for here, I'm going to just run a little scenario here. We want to look for late, and we want to look for capacity bottlenecks. So these are interesting. So when I click on a job in PlanetTogether, I immediately can see, based on some vertical lines in the Gantt, I can see when the job is due. What's cool is I know the job is due at midnight on on the 23rd, right? Right at the start of the day on the 24th. So I know that this operation needs to be completed by then. If I click on my mixing op, PlanetTogether actually tells me, well, the mixing op needs to be completed by this other red line, the op need date. All right. So watch what happens here. If I move my pelletizer past this red line, it turns red. It's late. Okay. Pretty cool. Tells me it's late. No brainer there, right? Pretty simple. Watch what happens though when, and notice it's by operation. So my mixing operation is still on time, but my pelletizing operation is late. Watch what happens if I move the mixing operation past when it's due. So the mixing operation turned red and my pelletizing operation turned orange. Now, both of these colors mean that the operations are late. But what's cool about this is that the red signifies what is causing my lateness. So in this case, my mixing step is causing this job to be late. All right, so pretty cool. I can immediately see why the job is late. If I move this back on time again, this turns red. My pelletizing operation is obviously causing my job to be late. That becomes important when we have a lot of data in the schedule and we really load it up. It's easy to identify bottlenecks at that point. I can see like, oh man, my pelletizers are totally bottlenecked. I need to do something about it. So before we load more data up here, I want to show. Well, we'll do it in a second. Just a second. There's some alerts here that we're going to create once I put some more data in, and it'll be a nice exercise. I'll show you how we can customize all the layouts for you. So let's turn a couple other colors on for us here. Let's turn on our attributes. So I put some attributes on these, basically like what type of resin and what color we're going to make the resin. If I apply that, you'll see that the resin is B and the ink is blue, and I just color coded this section to show blue. All right. I'm going to turn my process segment on like we saw before. It tells me how long the operation is going to run for. And I'm going to turn one more on, status. Status is going to tell me if my raw materials to run this job are available or not. So we're going to get some information on material availability. If I see like a beige color, it means all my material sources are planned. It knows where it's getting material from. If I see the purple color, then that means I've got an issue and I've got to go look at it. It's missing some sort of material. All right. So let's save that, and I'll talk about one more thing while we're kind of just have a very simple scenario, and we'll get into all these colors in a second. But notice on the screen here we've got an orange area. We call that the frozen area of PlanetTogether, the frozen zone. And what that does is that helps us lock down our jobs. So, you've got this automated system now, right? You've got this APS system working for you. And you don't want it shuffling all your work all the time around, right? I mean, you got a job that's due, that's scheduled to start in an hour. You don't want it to automatically shift because you put some other job in there. At least for today, you don't. You want to lock it down. So, so the frozen span helps us do that. And I'll give you an example right now. So if I were to run optimization, all right, and we'll get into how this works in a bit, but if I were to run optimization basically schedules my jobs, right? So if I optimize this, it moves my job to the front. If I move my job out and I hit optimize again, it moves it to the front. It wants it to be there, right? But I'm in my frozen zone. I kind of want to lock it down. So some of our options under optimize are, do we use the frozen span or not? And the frozen span is totally customizable. I could have a different frozen span on mixer or pelletizer, that sort of thing. I have it set to 3 days at the moment for both. But now watch what happens. I can still manually move jobs in this area, but when I hit optimize, they stay put. Now, if I was outside of this area, like I'll bring one operation, I'll bring it out here, and then I hit optimize, it moves up to that frozen span. It doesn't go in. So basically, the idea is that as work becomes completed, it moves into the frozen span. There's a nice compress option we have that we can compress work up into the frozen span, which is nice. So as your day progresses, your work becomes complete and the schedule moves along. Your jobs start to creep into the frozen span and become locked down. That way outside here, your schedule is more fluid. It can react to changes and that sort of thing. So that's the idea behind frozen span. It's a question we get a lot, like how do we lock down the schedule? And that's one of the ways. I'm going to turn it off for the rest of this demo, but just know it's there. All right, so we are going to, let's just flip back for a second onto our agenda here. So we've covered our resources and our job setup and some of our labels. We'll get to alerts in a second. We're going to start to look at, we looked at a little bit of bottlenecks and on-time delivery issues. What we're going to do now is we're going to load up the schedule with a lot of jobs. I think I'm going to bring in like 15 or 30 jobs into the schedule, and we'll see how that works. All right, so the way this works is we're going to start talking about the buttons up here. The typical data flow, like we talked about, right? We grab orders in from the ERP. So how that works is your scheduler would hit this refresh planning data button. That basically goes out to the ERP, brings in any of the new information. It's like all the resource information, the inventory information, and the routing information, new jobs, and that sort of thing. So I'm going to do that, and let's see what happens here. So we hit that button, and our refresh will start. Refresh started. And our refresh has completed. Now, what we see now is I get some alerts in my system. I see that I have 16 total jobs, and I increased it, went up from 1. That's what that little indicator means. I have 15 new jobs. I can actually click on the new job alert, and it will sort my list of just the new jobs that just came in. Now, we talked about optimization and kind of automatically scheduling jobs, and that's what we're going to do in a second. But just to give you one more idea and one more way to do this, PlanetTogether lets you drag and drop from your job grid onto the Gantt. So, for example, I could take this work order number 2 here, and I can just drag it onto the Gantt. So maybe let's put it on Tuesday the 24th. And there we go. I dragged it and dropped it. Now, I dragged it and dropped it, so it was late, but you can do that nice drag and drop from that grid. Now, let's kind of get more advanced here. We just want to schedule all this stuff, right? You're going to get new orders in. Let's schedule. Let's get it on there. All we have to do, hit our optimize button, right? So I'll go and do that right now. Okay, perfect. So all the orders are scheduled. We don't have any new jobs anymore. They've been scheduled. We can flip back to our all jobs grid. What you're going to see here now, remember we've got all of our colors, and you kind of see different resins have different colors, and now we see that there's some setup time here, not just runtime. So as we change over, we're getting some long changeovers in this data set. A couple things just to look out for here. This particular job is outlined in red because I've categorized it as a hot job. So that's standard flag and PlanetTogether if you want to identify hot jobs and maybe do some priority on them. We're going to do that in a second. You'll notice, though, we have one job that's late, one job finishing late. Now, we didn't really get an alert that one job is late. We just simply see it in the Gantt. So what I want to do is a quick exercise, show you how users can set up alerts to basically create these little custom alerts at the top here. So this is a job alert. I want to know when any job is going to be late. All right, so we come to our jobs list, and let's see. I'm on my all jobs view. Let's create a new view. Let's call it late orders. Save it. So now I have a view called late orders. Now what I want to do is filter my jobs view for only jobs that are late. And look at this. I've got a late flag. Now there's a lot of columns you can add here. Late is one of them. It tells you how late it is by an hour and 19 minutes. So let's filter our view to show me only late jobs. All right, now I can save that. So now I have a view. I can flip from all jobs to, let's see, late orders. All right, and see that one order. But that doesn't give us our little alert up here. So if I want to turn this into an alert, I hit the bell, and we just give it a priority. I'll give it critical. We'll just change the color of it. And now what I see up at the top here, I have one late order. So check this out. If I go to the Gantt, and let's move another order late. I'll move this one out just to see what happens. Nope. There we go. I should have 2. So notice that went up. If I optimize and get these back, it'll go back down to the 1 order. All right, so easy. Every grid in our system has alerts, has layouts. You can really do whatever you want with that. And you have unlimited custom fields that you can add. So really anything is possible in these grids. All right, so obviously this red, if we didn't get it before, this red is telling us we have a capacity bottleneck on pelletizer 2. That means we are bottlenecked on pelletizer 2. All right, quickly I can identify that. So let's next talk about doing some sequencing and some changeover reduction. This is the cool part. So what PlanetTogether does is I've loaded in something called an attribute. Let's open up one of these jobs here, this resin, this blue resin. If I open this job up, there's a lot of data in here, but I'm going to come over to my attributes. And these are all custom. You can load as many as you want into the system. But I have an attribute called ink, lightness, and resin. All right. The code is blue, resin B, and I have a lightness factor. Doesn't really matter, but maybe I want to sequence by going from light to dark, that sort of thing. So I can use that to do that. Now, there's a number of setup hours or changeover hours associated with each one of these attributes. And this field is telling me when to incur that setup. So basically says, if my ink changes, I'm going to incur an hour of setup. If my lightness changes, my lightness code changes, I'm going to incur an hour. If my resin changes, I'm going to incur 3 hours of setup. Okay, so let's take a look here at this job. So we go from resin B to resin B. That means that we don't incur any time there. We go from ink red to ink blue. We incur an hour there. And then I know for a fact that this color and this color, this is a light pink, and this is a dark blue, the way I designed this. So I change my lightness factor as well, and that means an hour of setup. So we basically should incur 2 hours of setup, and that's what it's telling me. So it's dynamically calculating that. Give you another example. Check this out. If I drop, I'm going to take this blue order and match it up with this blue order, and we should reduce all the setup. Let's do that. If I drop it over here, notice it totally eliminated the setup. All right, and I'll show you that again. If I drag this order out here, it gets 2 hours of setup because it's doing a changeover. If I drag it up in here, it reduces that setup. All right, so that's kind of neat, right? It's all dynamic. It's all happening for you. So, of course, you can go and drag and drop to your heart's delight, but, of course, the more orders you have, the harder that's going to be. So let's use the optimization power of PlanetTogether to do some sequencing for us, right? So I'm going to optimize this just to reset everything. So let's see if we can get some of these orders to kind of sequence together to reduce some changeover. This is a fun exercise. I love doing this. We've got something in PlanetTogether called key performance indicators. So these measure like different financial metrics throughout the system, production units, financial like throughput, revenue, WIP carrying costs, that sort of thing. One of my favorite ones, just for demo purposes, is this total setup calendar hours. So let me uncheck these. I'm just going to check one. And what happens on this KPI is like every time I do an optimize or any schedule change, it tracks this KPI. All right. So when I move that blue one up here and I save us a couple hours, you notice it went, let's see if I can get back to it here. It went from 80 to 81. We saved 1 hour. All right. If I optimize, it went from 80 back to 81. We lost an hour. So let's do some standard optimization here. PlanetTogether, like I said, has some sliders for optimization rules. They can be set up really by resource if you want to. Right now, I'm just using one rule for the entire system, but I can have different factors in that rule. So right now, we're optimizing by need date. And let's see. Let's come down to product. Actually, you know what we're going to do? We're going to add an attribute. So let's sequence by ink color. So what I'm going to tell it is keep the same ink together, keep the same attribute code. You can do different things. You can say like if you had numbers in here, you can say schedule the next highest attribute number. but right now we're just using code. And I say, if you keep the same code together, I'm going to give you 100 points on my score, right? Let's see what happens. So I've set my rule. I'm going to run optimize. And let's see. So we get, this is interesting. This is kind of neat. So we dropped by 10 hours of setup. And what is it doing here? It is looking at my ink color, and it's sequencing ink blue, ink blue, ink blue, ink blue. Different resins. I didn't tell it to keep my resins together. Ink red, ink red, ink red, ink green, ink green, ink green, ink green, right? So it's keeping, now it's keeping my inks together. Maybe we just want to do it by resin, right? So let's go to my attribute scan. Let's pull this one out. You know, you can add multiple in here too. Just want to give you an idea. Same attribute code. Let's add 100. Let's optimize again. Now we're keeping resin A, resin A, resin A, resin A, resin A, resin A, resin B, right? So you get the idea. PlanetTogether is doing some sequencing for us and helping prioritize these orders. Now watch this. This is a hot order, right? Remember I said maybe we want to prioritize this order? Well, we can come to our optimization rule. We'll keep the same one. Productivity. There's a slider in here that prioritizes hot jobs. Let's give this the most priority. And let's optimize and see where this job goes. Boom. So now PlanetTogether has prioritized that hot job outlined in red right to the front of the schedule. All right. So really simple ideas, but helps control, gives you as the user control of how PlanetTogether is going to do this prioritization. Now, for my last trick here with optimization, I'm going to reset these rules back to 0, and let's take our attribute out of there. There's one really cool rule if you have dynamic setup like I do in here, and it's just simply called, where is it here? Least setup hours. So I can actually just tell the schedule based on the current data in there. I can say, go and reduce change over my entire schedule. Go figure it out yourself. I don't want to tell you how to do it. You just go figure it out, right? So we'll put some weight on least setup hours. I'll save and close that rule. And remember, what are we at here? 63 hours. Let's see if we can do better. So I'll optimize this. Boom. So now we drop down to 26 hours of total changeover, which is great. We don't have any late jobs anymore. And we're sequencing our resins together. And we are getting some secondary sequencing of our inks, right? So that's the idea. That's the idea. It's pretty straightforward stuff, but it's super powerful. Super powerful. All right, let's go back to our agenda here. So we've done our general setup here. We talked about alerts a little bit and how to set that up. Looking at bottlenecks and on-time delivery issues. Of course, you can drill into, like I said, if you got late orders or whatever you want to set up, as you can drill into those issues, see the customer, go call them and tell them, hey, look, this is going to be an issue if you can't resolve it. We talked about sequencing and changeover a little bit. Let's go into just manual control for a second, and then we'll talk about material management. So manual control, we've really been focusing, I'm going to hide my KPIs here. We've really been focusing mostly on the Gantt view of PlanetTogether, which is a really great visual view. Sometimes, though, it's easier to schedule in more of a list format. So, and of course, you can kind of see it here. If I had a lot of jobs on this schedule and they're tiny like this, it would be hard to see what I need to kind of move around. Now, we do make it simple. You can click on jobs on the Gantt and they highlight on the jobs grid. You can also, I can right click on a job and find it, and PlanetTogether will zoom into it. Let me do that one more time in case you missed it. Let's do a different one. So it kind of highlights it and flashes it in blue. So that's great. That's easy, right? But let's kind of look at different options. So I'm going to minimize my jobs grid for a second, and I'm going to open up a view called activities. So activities is really cool. I'm going to put it side by side to Gantt just so we can see it. I call the activities grid the list view of the Gantt. Notice I've got my resources on the left-hand side here. If I click on Mixer 1, it shows me what's scheduled on Mixer 1. If I click on 2, it shows me what's scheduled on Mixer 2. And I can sort these if they're not already. I can sort them by their scheduled start date so they're exactly in order of what they are on the schedule. So why is this important? Well, check this out. Let's take this hot job, right? This one that I had categorized, this work order 15. Notice when I click on it on the Gantt, it still highlights it on the grid over here. So let's do that. And now, check this out. Maybe I want to drop this right behind my first order on the Gantt. I'm going to zoom in again a little bit. We can do that right from the grid. So all I do is click on it, drag it up to the top, let go, and it moved right behind my first order, and it shows it on the Gantt. That's where it moved to. So everything's synced. Everything you do is synced. You can even move chunks of orders. I can take both of these, move them up to the front if I wanted to, and it'll move both of those orange orders right up. All right. So that's all great. The second really cool feature about the activities grid is it's a split screen. So I can actually create the same view on the bottom. Check this out. Put my mixers over there so I can see the same thing, right? Here's my jobs. I mixer one up here, mixer one up there. I can do some drag and drop across resources here. So I can take this work order 13, which is this blue one over here, and I can drop it down onto mixer 2. And I can just do that really easily like this, and you'll see it move. So really neat cross resource planning in a list view. The advantage of the list view is that you can see all the data about all the jobs on that view. There's a lot, right? You can even see the colors, the ink color. It's a really great tool inside the system. Okay, let's talk about material management. I think we're at a good place here. So under the covers here, I haven't really shown you this yet, but PlanetTogether, like we said, is looking at material availability to determine if it can schedule. If I open this job up, we can actually see the BOM requirements on the job. So if I look at my stock materials required to run this job, it looks for resin B and ink blue, right? And it tells me that it needs this much of each one, and it tells me that it's getting it from some purchase orders that are coming in. All right, my purchase orders are coming on the 16th, so it's not causing a problem in the schedule. But let's say my purchase order came in late, okay? So let's say my purchase order came in on Saturday the 21st, beginning of the day. So let's just go modify one of these and I'll show you what happens. Let's take our resin order for resin A. I'm just going to open it up and let's move the date out to the 21st. Like we said, okay? I'm going to switch back to the Gantt before I save this. So I want you to see what happens. So I can save and close this and PlanetTogether adjust. Now, it initially adjusts because what happens is it must be this first order used resin A, so it pushes out in the schedule, okay? So you can imagine your purchase order changes after you refresh the data. This is the impact of your purchase order changing. It's going to push these orders out. Now, what you can do, though, is you can then optimize around this issue, okay? So we optimize, and there we go. My resin A orders, or any order using resin A, got pushed out in the schedule because it's being constrained by that purchase order coming in. It can't schedule any earlier. I can even try to move it, and it won't let me because it's waiting on this on the resin. And you can see everything's got resin A. Now, what's interesting here is, I'm going to run optimize one more time. Notice the color on these orders. So purple, we'll go back to our label settings. This is kind of neat. Purple in this case means that the job is late and it's due to a material bottleneck. So it actually shows you capacity bottlenecks in red, and it shows you material bottlenecks in purple. Now, what's nice about this is it still is constrained by material. So nothing's actually short. It's just pushing it out in the schedule. But let's make it short now. Let's change it so we're actually short on material. Let's go back to my purchase order, resin A. I'm going to set this to set it to the 16th again. And instead of bringing in 1 million units of this, let's just bring in 400,000 units. Let's see if this. Let's just make sure. Let's make it really short. 300,000 units. Okay. So I can save this. So now in my schedule, I should have shown you it again before I saved that. I'm going to hit optimize again. Now in my schedule, we see some different things. We see that, notice, remember the bottom color? If the bottom color turns purple, it means that there's a material shortage, all right? It doesn't know where it's getting the source of that material from. And if I click on this order, the order now, instead of scheduling where the PO is coming in, because the PO is coming in early, but it's only affecting this, these couple orders, not all the resin A's. Some of the resin A's are able to schedule. You're able to see that it's scheduling at the lead time of resin A. If I try to move this sooner, I can't do it, right? So that's the idea. The entire schedule is constrained. Now, the couple alerts, or just a couple asides of that, is you can quickly show material shortages. There's a material usage report, which basically shows every adjustment of material in the system. I can go to that report, and it'll tell me the jobs that are affected, how much quantity they require, and then how short they are. Let's see, there's a column over here. Unavailable quantity, that sort of thing. So quick view to just as an alert to say, hey, look, this is we've got some shortages here going on. The other view is our inventory plan. This is pretty neat. So we can show some shortages on our raw materials here. I've got everything categorized as raw material, but you should just ignore these. These are actually finished good materials, but or finished good products. But if I look at resin A, we can see the adjustments in the schedule. This is pretty neat. We actually started with 300,000 from that purchase order, remember? And our current on hand at the beginning of the schedule, I guess there is no adjustment change. And then we have jobs that are using that material until the 18th when we run out, and the next job schedule is on the 25th. So what's cool about this grid is, for resin A, we can see that our first shortage of this material is on the 25th. That's when we have a scheduled usage of it, and we drop below our supply. So different views in this screen. This you can manage your inventory basically. Here you can see the adjustments of each item, how it's been used, when you're going to run out. And PlanetTogether, I mean, there's always columns. There's always more data to be seen. I mean, I'm only showing 7 columns here, but there's a lot more information to be shown here. All right, a couple more topics before we finish up here. Thanks for sticking with us. 2 more. We've got what if scenarios and capable to promise. A couple quick topics here. So let's do this. Let's reset our purchase order, get these things scheduling the way we want. And remember, all this data would be automatically coming in on your integration, right? Your changes in purchase orders and on-hand values and all that stuff. Typically all managed outside of PlanetTogether, and we just import the data. You can, of course, manage it in PlanetTogether if you want. So let's optimize. All right, so the request is, the scenario is, we've got 2 scenarios. One scenario is, you know what, we want to see what happens if we bring another pelletizer online or take pelletizer 1 down for a couple of days. I really don't want to do it in my live system because my shop floor is looking at it. So how can we do this? Well, we can do it by doing a what if. So notice I've got a scenario up here, live scenario 1. I can create a what if scenario pretty easily. A what if scenario is an entire copy of your data set. So, and it's pretty disconnected. You can actually import data into the what if you wanted to. So I have another option now. I can say only bring in new data for this scenario, so I can run kind of data analysis in here. But notice on the GAN it says what if. I can change the name of the what if I want to. And now I can kind of play here. So let's do a couple things. Let's take pelletizer 1 down and see the impact, right? So capacity tools, let's take it down for 2 days. Let's take it offline. I can simply set my settings here and then click on pelletizer 1, and it'll put an offline interval here, okay? So it puts this little gray bar here, which says you can't run anything. at that time. Now you immediately see the impact by doing that. All the orders on Pelletizer 1 push, right? So we see that, oh, we have 3 orders that are late, that sort of thing. But now let's optimize around that offline time. And what do we have? Okay, so by doing that, our result is we're probably going to have these 2 orders that we need to do something about. So maybe we got to figure something out to do, or we got to call these customers and tell them they're going to be, maybe another day delivery on those. All right, so that's one option. Now, what's really cool, here's a second kind of idea. Usually when you want to add a new resource to a system like this, you have to add it through your ERP and kind of import it in, and it's kind of a big deal. But let's say we want to bring another pelletizer online. So we can just simply duplicate this pelletizer. Now, it names it copy of pelletizer 2, so alphabetically it sticks it up here, but you can come in here and rename it. But essentially, I can add a new pelletizer, I can optimize, and basically see the effect of that. I could then, say we're bringing on a pelletizer in a month, I could take this offline for a month and then see the effect of what that's going to have, in a month when it comes online. So different scenarios you can run. What's great is you can do all this in your what if. I can switch back to my live. Loads up all the data for the live scenario. Come back to my Gantt, and notice I only still have 2 pelletizers and it's not offline, so it's all contained in my what if. Now, when I'm in my what if, I'm not going to switch back right now, but I can. You can convert the what if to your live scenario and then delete your live. So some of our customers like to run all their scheduling changes in a what if and then convert it to live, that sort of thing. When you're done with your what if, you can go in there and you can also just delete it. There's an option when you're in the what if. There's an option here to delete. Pretty easy. So I call that, let's call that what if type number 1, kind of creating a what if scenario. The other type of what if in the scenario is called a capable to promise. Basically, what if we get an order in for this amount and it's due on this date? What's it gonna do to our schedule? All right. So this is this functionality here. It's called CTP, capable to promise. What I can do is I can pick an item. So let's pick, let's expand this a little bit so I can actually see what's going on in here. Let's pick, I don't know, let's pick this blue, ink blue here, dark blue resin B. So pick this item. The quantity is, let's see, these are around 100,000. So let's do a 200,000 unit order for this, okay? And we need it, man, I think we need it on the 20th. Let's say we need it on the 20th, all right? So the question is, can we get it done? Well, we can optimize it into the system and just see if we can. So let's do that. Let's submit this. So let's see. It says it could start it on the 18th. So it could start it right at the beginning of the schedule and finish it. I guess finish it that night. Okay, so it's a long order, so it can do it. But what's the impact of that, right? Is there an impact? So let's find out what the impact is. So this tells us, yeah, we can get it done on time. Let's just see what the impact is. Let's reserve the capacity for this capable to promise order. Basically, we're going to create a job for this and put it on the Gantt and see what happens. All right. So let's submit this. I'm going to move this out of the way a little bit. So we'll submit this order. Okay. Now what it did was it pushed it into the schedule. You can see it here outlined in blue. It basically locked it down. So it's a little hard to see, but it's there in blue. Actually, if I turn on a status called commitment and turn maybe off, turn a couple of these off just to show you, you'll notice that everything else is firm in the system. All the firm orders are white for this segment, but that CTP is in an estimate status, so you can see it there. Now, what's great about this is we scheduled this order. It's on time, and it's actually scheduling a little earlier because we release it a little earlier before it's needed. So it could actually schedule out a couple days. But the most important thing is it's not causing any other orders to be late. So that's great. We've submitted a CTP request. You can keep this job on the schedule if you wanted to, and you can delete it when you get the actual order in. And that's the idea, right? You can reserve the capacity. The option up here says, if I don't get an order in by the 27th, or I could make it sooner, by tomorrow, what PlanetTogether will do is it will actually delete this order automatically. So basically, it's reserving space for a period of time, and if your order doesn't come in, it just gets rid of that order. So really useful feature in the system, and yeah, a lot of our customers really like it. And of course, if you want to delete it, you just delete it. Pretty easy. All right. So that is that's the demo for today. Really, the purpose again was to give you a little history on PlanetTogether and its APS system, and to really give you just a look and feel demo of the product. I'll go back a slide. We hit a lot of the major areas that people are concerned about typically. So, how does it look, right? How do you set up a job? What types of alerts and colors and kind of notifications can I get when I'm scheduling? How do I identify on-time delivery issues, right? How does the optimization work? I hope I give you a little, shed a little light on how that works and how you can control the sequencing and reduce your changeover times. How easy is it to schedule? I'll leave that for you guys to decide, but there's a few different ways inside PlanetTogether. It's very visual, drag and drop capable. From my point of view, it's pretty easy. But of course, you guys be the judge. And we showed that you can constrain by not only capacity, when are your resources available, but also by the raw material inventory and on hand that you have to schedule those jobs. And then, of course, one of the most requested features is the what if functionality and the capable to promise functionality. All right, so that's it. I highly suggest, if you enjoyed this demo, reach out to PlanetTogether or your PlanetTogether partner for next steps, and typically we'll do a discovery call, kind of understand what your needs are and determine if we think we can help you, and we'll go from there. So thanks for joining today, and have a great day.